Okay, so to start with, let's take a look at just are you ready? So the are you ready part comes before every chapter. So like you see on the first page, it's just chapter 6. That's the first page of chapter 6 in your books that you guys have available online. And the next thing it says, are you ready?
Chapter 6?
Yeah, chapter 6. So the next thing it says is, are you ready? So this is going to just ask us a couple questions to see if we're ready for the chapter. So the first question is exterior angle. Which one of those letters matches an exterior angle? Or let's do it this way. What about A? Is there one that matches A? Lines that intersect to form right angles. Perpendicular lines. Good. Let's see if there's one for B. Lines in the same plane that do not intersect. Parallel lines. Good. Two angles of a polygon that share a side. I don't know if there is that one. Two angles of a polygon that share a side. I don't think there is one for that. A closed plane figure formed by 3 or more segments that intersect only at their endpoints. That's a polygon. That's a kind of complex definition of a polygon. A 4-sided polygon is a quadrilateral. And then this last one is an angle formed by one side of a polygon. So here's a polygon and the extension of a consecutive side. So that angle there is an exterior angle. Does that make sense to you guys? Okay. So that's the are you ready? And then here's just another question here. It says find the value of x. What do I know about the interior angles of a triangle? What do they add up to? 180. So I would do x plus 32 plus 42 equals 180, right? So x plus 74 equals 180, and then subtract 74. Does this make sense? X equals 106. Does that make sense, guys? Okay, so that's just a little bit, just to prep us. And then we'll move into our actual lesson for the day. So our actual lesson for the day is Chapter 6, Lesson 1. So let's go ahead and get into that. So properties and attributes of polygons. So this list right here has all the polygons and the number of sides. Yes, sir. Yeah, go ahead. Okay. So number of sides and the name of the polygon. So if it has 3 sides, it's a triangle. 4 sides, a quadrilateral. 5 sides, a pentagon. 6 sides, a hexagon. 7 sides is a heptagon. That's one that a lot of people forget. 8 is an octagon. 9, nonagon, so it almost sounds like 9. 10 is a decagon. 12 is a dodecagon. For whatever reason, they skipped the one with 11 sides, and I don't really know. But if you get up to like 30 sides, there's not a name for it. They just call them a 30gon. Cool. Because after a certain point, it's just like, we don't need to create more names. That's silly. So it's just like a 40gon or an 80gon or whatever it needs to be. Okay. So here's an example of polygons. So here's a polygon. It's got 5 sides, so it's a pentagon. This is not a polygon because you see it's got these crossing lines in it. Okay? It's got to be a closed shape. Now, each one of these is a polygon. Each one of these is a triangle. But that whole thing together is not a polygon. This is a polygon because it's a closed shape with all straight sides. Okay? Now, 1A, raise your hand if you think this is a polygon. Raise your hand if you think it's not a polygon. Good. Why isn't it a polygon? Someone that raise their hand. Because it's open. What about 1B? Raise your hand if you think this is a polygon. Yes, it's good. 1C, raise your hand if you think this is a polygon. Raise your hand if you think it's not a polygon. Why is that not a polygon? It's got a curved side. Okay, cool. Hey, Andre. Got it.
Oh, yeah.
Your friends knew about you. You having lunch with a teacher?
Oh, yeah.
Yeah, cool. You're good. Thank you. Okay. Now, what about a regular polygon? Now, if you're taking notes, which you should have a piece of paper in front of you for notes, in this class you should always start out with a piece of paper and then title it Lesson 6.1 Properties of Polygons and Quadrilaterals. You should have that available. You don't always need to take notes for every single thing I say, but you should take notes for the important things. Like if I write something specifically on the board, you should be taking down notes. That says regular polygon. And what this is all sides are congruent and all angles are congruent. What's an example of a regular polygon? There you go. These are all regular polygons. Because if you look at them, all their sides are the same. All the sides and all the angles are the same. The technical way to say it is equiangular and equilateral. Equiangular and equilateral. Equiangular and equilateral. Angular is obviously for the angles, lateral is for the sides. So equiangular and equilateral is a regular polygon. Yep. Yep, sure. Okay. Now, let's take a look at some of these. Because what we want to figure out is the sum of the interior angle measures in each one of these polygons. Okay. So we know the sum of the interior angles in a triangle is equal to 180. Question is, how many? Actually, before we get into this, let me just give you one thing. Let's actually test our knowledge. Okay. Let's say I give you this shape here. This one here. Okay. Now, there are two types of polygons. There's convex polygons and concave polygons. You can go. And guys, let's make sure we use the restroom in the first 5 minutes of class so we're not interrupting. So concave and convex. Okay, this is, let me show you.
If we don't need the numbers, is it okay if I sit back up?
Mm-hmm. So, a convex and a concave polygon. Check out this picture right here. So, a convex polygon, look, a convex polygon has all sides that kind of look regular. They kind of open outward. A concave polygon, it looks like one thing is caved in here. Does that make sense to you?
It's flat.
Oh, sorry. So we have a convex polygon and a concave polygon. This is what it looks like. All right, this is what a concave polygon looks like. Let's give an actual definition. Let's give an actual definition. So let's say I draw a polygon like this. First off, who can tell me what kind of polygon that is? Pentagon. Pentagon. 1, 2, 3, 4. No, quadrilateral, right? So it's quadrilateral. It's got 4 sides. Now, if I draw a line, first off, what are these points called here? Do you know what those points are called? Vertices or a vertex. Each one is called a vertex. No. Vertice is just the plural of vertex. Okay. And each one of the sides, so here's a side, here's a vertex. Now, if I draw, God bless you, if I draw a line from one vertex to another vertex, that is called a, does anyone know the name of that? A diagonal. It's called a diagonal. So I can draw all the diagonals just like this. Okay. Cool? That's a diagonal. Now a concave polygon has all the diagonals on the inside. Okay? All the diagonals are fully on the inside of the polygon. So you can write that down. All diagonals inside. All diagonals inside. Okay? Now, a convex polygon
You switch it up because concave is caving in, right?
I'm sorry, convex. Yes, thank you. It's convex. Sorry, convex. Thank you. It's a convex polygon. All diagonals are on the inside. But let me draw another polygon now.
Just copy.
What's that?
Yeah.
What'd you say?
Other than that, we thought that.
Yeah, exactly. Thanks, Sam.
Convex.
It's convex, sorry. Convex. And you'll see why in a second. So that's the technical definition, is all the diagonals on the inside. But this one is clearly a concave, because it looks like one side is caved in, right? Does that make sense? But what's the technical definition? Well, let's draw the diagonals. So I'm going to draw, I'll draw from this vertex to that vertex. Okay, that one looks good. That's on the inside. And then from this vertex to that vertex. Well, that looks good. That's on the inside. And then from this vertex to that vertex. Well, that's fine. That's on the inside too. But then look what happens when we draw from these vertexes to the other one. You see that? The diagonal is not fully on the inside, and this one too. That diagonal is also on the outside. So the technical definition is some diagonals on the outside.
It's called a concave because it's caved in.
Yeah, it's caved in. Okay? Caved in. But technically speaking, if you really wanted to say it, you wouldn't say, oh, it's caved in. You know, it's there. Some of the diagonals are on the outside. Does that make sense?
Alright, so then like on the test, would you be like, what makes it a concave?
No, I would be more like, is this a concave or a convex polygon? But it's important that you guys understand, so you're not just like, oh, it's caved in, you know? It's like that you understand the deeper meaning of it. So with that, I can start asking you guys a couple questions. So this shape right here. First off, is this shape concave or convex? Convex. Very good. It's convex. Second off, is it equilateral?
Yes.
Because all sides are congruent, right? Equilateral. Is it equiangular?
Yes. No.
Are all the sides equal? Are all the angles equal?
No.
Yes.
No, these
Oh,
two
no.
are the same and these two are the same, but they're not the same to each other.
So
So it's not equiangular, right?
it's only equal angle if they're all the same?
All the angles have to be the same.
Wait, what's for equilateral?
All the sides have to be the same. So it's not equiangular. Not equiangular. So is this regular? Is this a regular polygon?
No.
Yes.
No. It's not regular. Or, in other words, it's irregular. Irregular. Why is it irregular? Because in order for it to be regular, it has to be both equilateral and equiangular. All the sides and all the angles must be equal. Does that make sense? No? Yes. Kidding? Okay. It's equilateral, means all the sides are the same. It's not equiangular because not all the angles are the same. You see? So therefore, it's not a regular polygon because it doesn't satisfy both of the conditions. Yes, sir.
Show a shape that is equilateral.
Yes. And equiangular, of course.
Call it a regular polygon?
Yeah, I'll show you a regular polygon. Yes, ma'am?
No. It's,
Mhm.
So it's called an irregular polygon.
It's called an irregular polygon, exactly. So,
So everything has to be equal, basically. Like this
Yep.
side.
yeah, it's all just got to be equal. Does that make sense?
Yeah.
All the things have to be equal
To be what? It has
to be a regular. To be regular, think about it. Like, if it's a regular polygon, oh, it's regular. So all the sides are the same, all the angles are the same. This is all good. Yeah?
Yeah, it's alright.
Okay.
I
So,
was gonna ask you what it was, but it kind of helped.
yeah. Thank you. Thank you. I appreciate that. Things like that have to happen before class, or it could have happened while you were in the bathroom. Oh, nice.
Unless you are dehydrated.
Unless you are about to die, then you can definitely
No,
look at water.
I mean, first
Okay.
of all,
So this one was not regular. Why? Because these angles.
Some angles were equal.
Oh yeah, you know today's Newton's birthday.
Mm-hmm.
We
So-
should pretend she's here.
That would be fun. So, it's not all the angles are equal, but look at this one, guys.
Wait, all the angles?
Shh. Look at this one. This side, this side, this side, and this side are congruent. So what is it? It's equilateral. Equilateral. Guys, you guys follow football at all? Marcus does. If you do a lateral play, where do you toss the football? To the
Left.
side, right? If you make a lateral,
Left or right?
you toss the ball to the side, right? There you go. Lateral side. You see? Lateral is a side. You see? So equilateral means equal sides. Yeah. Okay. Now look at these angles. Shh. Look at these angles here. What do I know about all of these angles? They're the same. So what is it? Equiangular. So is this a regular polygon?
Yes.
Yes, it is a regular polygon. And is this concave or is it convex?
Concave.
It's convex.
What's the difference between
Can I ask a
convex
question?
and concave?
Concave looks like it's caved in. No. Calling it. Sorry. Guys, restroom needs to be done before class starts. Yes, I get it. Yep, Priscilla, you can go. You're the last one that goes for the rest of the semester.
Oh, wow.
First of the semester?
Until you guys can go in the last 5 minutes of my class.
Wait,
It's an emergency.
yeah.
Then you can call your parents and have them send me an email. All right, so we gotta keep. You see how it interrupts lessons though? Every single time someone goes to the restroom, can I go to the restroom? Yeah, they gotta come in. They gotta come back in. I'm taking up time, and it's taken away from you. I'm not just trying to be mean. I'm trying to make sure I'm responsible for you guys' education, which I am. Okay, so let's look at number 18 here. Just for the record, guys, I don't know if you guys have realized it, but when I give you quizzes and Kahoots and stuff, it's all straight from your homework. So just letting you guys know that. First off, is this concave or convex?
Concave.
Concave. Is it a regular polygon?
No.
No way. It's not a regular polygon. These angles are all different, right? Is it equilateral?
No.
No, those sides are definitely different too, right? So it's not equiangular, it's not equilateral, definitely not irregular. It is for sure concave. And if we look at it, if I draw the diagonal from this vertex to this vertex, that diagonal is on the outside. So that's showing us that it's concave. All right. Any questions about that? Okay.
Would 17 be concave?
Would 17 be concave? Hold on. Sorry. Would 17? 17 is not even a polygon because it's closed together. It's got to be open on the inside. Does that make sense? Okay. Okay. So, now let's talk about, so here you go, look, irregular, convex. Why is this one irregular?
Because they're all the sides are equal.
The sides aren't equal. This is regular. Why?
They aren't equal.
All the sides and all the angles. This is irregular. Why? Look, not all the angles are equal, right? There's no way for it to be concave and for it to be regular. It's not going to happen. So, it's concave, so it's irregular. Yeah, cool. You guys seeing it? You getting it? Okay. So now let's take a look at this right here. Let's take a look at this. So here we have different polygons, a triangle, quadrilateral, pentagon, hexagon. Cool. What's the sum of the interior angles inside of a triangle? One. It's not a trick question. 180, right? So if I break up these other polygons into triangles, I can figure out the sum of their interior angles. Because look, this triangle's 180 and this one's 180. So there's two triangles. What's the sum of the interior angles in a quadrilateral? 180 plus 180 is 360. You see this? Look. A quadrilateral has two triangles, so it's 2 times 180 is 360. You see that? A pentagon has how many triangles, class? 3. So it's 3 times 180, which is 540. So the sum of the interior angles in a pentagon is 540. You seeing this? What about a hexagon? How many triangles are there? 4. So every time I add a side, I add another triangle. You guys see that? 4 times 180 is 720. Yes, ma'am?
Wait, what's a convex irregular?
Convex irregular is just what it doesn't cave in, but then maybe one of the sides is a different length or the angles are a different length. So let's take a look at this. So if I have 3 sides, I have 1 triangle. 4 sides, I have 2 triangles. 6 sides, I have 4 triangles. How many triangles would I have if I had 10 sides?
1,800.
Look, if I have 6 sides, I have 4.
Oh.
If I have 5 sides, I have 3. If I have 4 sides, I have 2. If I have 10 sides, I would have 8. Why? 2 less every time. So if I have n sides, I have n minus 2 triangles, right? And then depending upon the number, pay attention. Depending upon the number of triangles that I have, that's what I multiply by 180 to get the sum of the interior angles. Is that pretty clear? So if I have 6 sides, it means I have 4 triangles. The sum of the interior angles is 4 times 180. Does that make sense? Marcus, why don't you come sit over here? Thank you. So if I want to figure out the sum of the interior angles of a polygon, all I have to do is n minus 2 times 180. So I take the number of sides, I subtract 2, and I multiply it by 180. So, class, so the equation is n minus 2 times 180. Okay? So if my number of sides is equal to 12, what's the sum of my interior angles?
10, right?
It would be 12 minus 2 times 180, right?
Or it'd be 10.
12 minus 2 is 10 times 180. What's 10 times 180?
That's like 1,800, right?
1,800. Does this make sense, Olivia?
Yes, sir.
Okay, so Olivia, if n is equal to 8, okay, what would my equation look like? What would my formula look like?
It would be
What would I plug in for n?
8
Okay.
minus
Mm-hmm.
10, 2.
2. Look at
And
here's
then-
my formula.
Oh, okay, and then minus 180.
Times
Times
180. Okay, so 8 minus 2 is
6.
6. Good. So we do 6 times 180. And if we can't do that in our head, we can just write it out. 6 times 0 is 0. 6 times 8 is what, class? 48. 6 times 1 is 6, plus 4 is 10. So 1,080 degrees. Does that make sense to you guys? If I want to find the sum of the interior angles, I have to remember that formula. N minus 2 times 180. Interior angles. So the sum of interior angles is equal to n minus 2 times 180. Does that make sense to you guys? Where n, what is n in this case, class?
Number of sides.
N is equal to the number of sides. And remember, guys, I'm recording this whole lesson. It's going to be on YouTube as well. Okay, any questions? All right. So how can we solve a problem with something like this? How can we solve a problem with something like this? Well, what about if I ask you something like this here? I say, here's my polygon, and I say solve for C. Okay? What kind of angles are all of those angles there that are marked as C? Interior or exterior?
Interior.
Interior. They're all on the inside, so they're interior angles. Okay. How many sides do I have? 4. So N is equal to 4. N equals 4. What was my formula again? You guys remember my formula?
N minus 2
Times 180. So if I want to find the sum of the interior angles, that would end up being what? 4 minus 2 times 180. Or 4 minus 2 is 2 times 180. 2 times 180 is what, class? 360. Or you could just remember that it's a quadrilateral, so the interior angles add up to 360. Okay? Quadrilateral adds up to 360. But why did I find that?
You know how many triangles are inside?
Yeah, because they're 2. You know, however you want to do it. But why did I find that? How does that help me to find the sum of the interior angles if I want to solve for C? What should I do?
times it and minus for, like, set it equal.
Set what equal?
C, 360.
So you would be adding them.
Yeah.
The sum of all of these interior angles equals this. Remember, this is the formula for the sum of the interior angles. So the sum of the interior angles, I add them all up and set them equal to 360. So I get C plus 3C plus another C plus another 3C equals 360. Or 1, 4, 5, 8C equals 360. Divide both sides by 8. And if I can't do that in my head, I can do my long division. Does 8 go into 3? Does 8 go into 36? How many times? 4. 8 times 4 is 32. 36 minus 32 is 4. Bring the 0 down. How many times does 8 go into 40? 5. So C equals 45 degrees. You could, but I'm just asking you to solve for C. Does that make sense?
So
But if I wanted to find these angles, yeah, I'd plug 45 in. So if I said solve for the angles, well, these ones are just 45 degrees, right? Those two there. And then these would be 3 times 45. 45 times 3 is 15. 3 times 4 is 12. 135.
Wait,
See?
do you get 8 by multiplying the number of sides by 2?
No, it just add them all up. 1C plus 3C is 4C, plus another 3C is 7C, plus another C is 8C. You had a question, Olivia?
Which one do you do? The n minus 2, or do you do c plus 3c plus c?
No. N minus 2 times 180 gives me the sum of the interior angles. So the sum of the interior angles is equal to 360, which means they all add up to 360. Does that make sense to you guys? So that's how I could apply algebra.
Wait, can you read
How did you count that up again? You went
What's 1 plus 3?
space 4.
What's plus another 3?
That's 7.
Plus another 1. Yeah. So that's 1C, 1, 4, 7,
So you
8.
don't count the C that's next to the 3.
No. This is 3 C's. That's like
Oh,
C plus C plus C plus C
Okay.
plus C plus C plus C plus C. Does that make sense?
Yes.
Okay. Any questions? All right. Now, almost. The last thing is this. The exterior angles, look, notice that these are exterior. You see these? You see how all these angles are exterior? Look. This is an exterior angle. This is an exterior angle. This is an exterior angle. These are all exterior angles. Do you see that? Those are exterior. They're on the outside. Okay. If you look, they're all being added up. And what do you get? 360. Added up, 360. It doesn't matter what the shape is, as long as it's convex, not concave. If it's concave, it's different. But if it's convex, you see both of these polygons are convex, then their exterior angles always add up to 360.
Why is
So-
that?
Well, I could probably prove it to you, but it's more.
Just like take the word on it.
Well, just if you look at it visually, it kind of makes sense because the more sides you have, the smaller the angles would be. So convex exterior angles all add up to 360 degrees. Does that make sense? All the exterior angles add up to 360 degrees. Is that pretty clear? All right. So how could I use this in a question? How could I use this in a question? Well, what if I give you something like this? All right, you know what? What if I give you something like this? And I say solve for R. What do I know about all these angles? What type of angles are they? Exterior. So what do I know about their sum? They all add up to 360. So I do 4R plus 7R plus 5R plus 8R equals 360. 4 plus 7 is 4 plus 7 is 11 plus 5 16 plus 8 4. 24R equals 360. Divide both sides by 24. We get R equals 15. Is that pretty clear? All right, you guys ready to Kahoot? Yeah. What was that?
Every time it's exterior, it's equal to
Add up to 360. Okay, so get your devices out. Okay. 15. All right, let's go. Kahoot and then a quiz. We have a limited amount of time, so.
I don't like how the quizzes are only 5 questions. Because if you get one wrong, it loses on your grade.
I understand.
Wait. Did you fix the 3 over 5?
No, I haven't fixed that yet. Sorry. I will. I'll do that today. Okay. 10, 9, 8, 7, 6, 5, 4, 3. Oh, that's everyone. 2, 1.
Oh, I spelled my name wrong.
It's all good. You're Macus, man. What's up? Name the polygons shown in the outline shape. You gotta count the sides for this, obviously, right? Decagon had 10 sides. Dodecagon has 12 sides. Pentagon has 5 sides. Peter Parker's in the lead. Spidey senses. Describe the polygon. Is it regular or irregular? Is it concave or is it convex? Oh, I might not change the answer to this one. It's regular and it's convex. Good. Describe the polygon. Regular or irregular, concave or convex. Irregular because not all the angles were the same, and it's concave because it caved in.
Good job.
Solve for y. Solve for y. You got a minute. Best out your pencil and paper.
Paper and pencil.
You add them all up. Remember, what do the exterior angles add up to? 360. You add them all up. Set the equal to 360 and you divide to solve. Good. Last one. Last one, and then you guys have your quiz. Solve for x. What type of shape is this? Quadrilateral. What's the sum of the interior angles for quadrilateral? 360. So you add them all up and then set them equal to 360. Because remember, it's n minus 2 times 180.
These are the interior, not the exterior.
The sum of the interior angle is n minus 2 times 180. So you add them all up and set them equal to 360 because it's a quadrilateral. You weren't here for this part. You were, I mean, you were here for like the back end of the code when I was writing the equation. Remember, it's n minus 2 times 180, right? How many sides are there? 4. 4 minus 2 is 2. 2 times 180 is 360. Add them up. 110 plus 130 plus x minus 10 equals 360. Can someone get that, please? 110 plus 130 minus 10 is 240 minus 10 is 230. Plus 2x equals 360. Subtract 230 from both sides. Are you guys following this? 2x equals 130. Divide by 2, and then x equals 65. Does that make sense? Yeah, she's good.
Can I
Yeah. Okay.
She called her Andrew. I was like, who's that?
All right. Quiz. Go for it. Quiz. My CCA. Quiz is up. The first 3 questions on that quiz are pretty easy, I think. So everyone should be able to at least get a 60. There's like no math. So make sure you take your time on those first 3 questions.
A 60 is not a good grade.
I'm just saying you should get at least a 60. Then the next 2 questions, you gotta be able to do that math, y'all.
What's the shape of pi sides again? I forgot.
You can look in your book.
Is it a hexagon?
Guys, if anyone wants the book for that first question, I'm gonna be glad to surprise you. It's open book, not open teacher's brain. That'd be fun, right? Every quiz you could just ask the teacher.
That's right, right?
Guys, remember we're taking a quiz right now.
Wait, but it's possible for it to be regular and concave.
I think I put the wrong answer to that question.
Which
So
one?
we do.
Just I've asked everyone to get the
Which
right
number?
answer to that one. Don't worry about it.
Wait, the ones that
The one that looks
Oh,
like
yeah,
a
so
cigar.
wait, can a concave be?
If I put the wrong answer to that, then
We have the right answer.
that's what the right answer should be.
So everyone will get it right no matter what they do.
Should be. If I put the wrong answer to it, then everyone will get credit for it. And I think I did put the wrong answer. But don't worry about it. Just focus on getting it right.
Oh, brother.
Oh,
Oh, really? Wait, I can't get it back.
Seriously? It's fine. I can do it in the Bible.
No, just finish it up. Finish it up.